You are going to watch an experiment to study the characteristics of the PN junction diode. Welcome back to my physics classroom. This is the apparatus for studying characteristics of PN junction diode. To study the forward bias characteristics, we have a diode connected in a forward bias mode. Forward bias means the positive of the diode is connected to the positive terminal of the battery, and negative of the diode is connected to the negative terminal of the battery. To read the forward voltage applied between the PN junction of the diode, we have a voltmeter. To study the forward current through the junction, we have a milliammeter. First, gradually we increase the forward voltage Vf and note down the corresponding If values. I am gradually increasing. I am keeping it 0.1. This is the 0.1 volt because the 10 divisions are equal to 0.2 volt here. So 5 divisions is equal to 0.1. So I am keeping the voltage value at 0.1. This is the forward voltage Vf, and note down the millimeter reading which gives the forward current If. So millimeter shows 0. There is no deflection for 0.1 volt. Now gradually we will increase the voltage to 0.2, still no deflection. 0.3 volt, no deflection. 0.4 volt, no deflection in the millimeter. 0.5 volt, there is no deflection. And 0.6 volt, there is a slight increase in the forward current. So here we are having some 1, 2, 3 divisions. So here 10 divisions are equal to 2. So 1 division is equal to 0.2. So that is equal to 0.6 milliampere. Then increase to 0.7 volt. 0.7 volt, what we are having? 1 division less than 2. 1.8 milliampere. 1.8 milliampere. Now increase the voltage to 0.8. 1 division after 3, so 3.2 milliampere. Let us see the calculation part for this experiment. We have a tabulated reading for forward voltage Vf and If, forward current If. We have to draw a graph between forward voltage Vf and If. Vf is taken along the x-axis and If is taken along y-axis. Now you are seeing a graph like this. If you see the graph, you can see up to 0.5 volt. Up to 0.5 volt, there is no forward current. You can see in the graph. After 0.5 volt, when the voltage, forward voltage is increased beyond 0.5 volt, there is a little forward current that you can see from the graph for 0.6 volt. For 0.6 volt, there is a small forward current, say 0.6 milliampere. Afterwards, there is a sudden increase in the forward current. So the forward current is increased exponentially. You can see from the graph. So the 0.6 volt is the knee voltage because up to 0.5 volt there is no forward current, that is because of the barrier potential of the diode. So after the forward voltage is increased beyond this barrier potential, we are seeing a increase in the forward current. So the 0.6 volt is called as knee voltage. Now to find the forward resistance of the diode, you have to take a slope. So take slope. For taking slope, draw 2 lines from y-axis so that the lines meet the curve at some points. and where the lines met the curve, draw two vertical lines, and those lines will meet the x-axis at 2 points. So take the distance between the 2 points from y-axis and the 2 points from the x-axis, and that will give the slope for this graph. Here we are getting a slope of 0.5 milliampere divided by 0.04 volt. So forward resistance can be calculated by taking the inverse of the slope, that is 1 by slope. So forward resistance Rf is equal to 0.04 volt divided by 0.5 milliampere. To change these values into SI units, you have to multiply the milliampere value 0.5 milliampere by 10 to the power minus 3, so that we will get the value in ampere. So 0.04 volt divided by 0.5 in 10 to the power minus 3 ampere. By dividing these two values, we are getting a value 80 ohm. That will be the forward resistance of this diode. To study the reverse bias characteristics of the PN junction diode, the PN junction diode is connected in the reverse bias mode. The reverse bias mode of connection means the negative of the diode is connected to positive of the battery, and positive of the diode is connected to the negative terminal of the battery. And we have a micrometer to measure the reverse current, and also we have a voltmeter to measure the reverse voltage. And now we have to increase gradually the voltage, reverse voltage value, and note down the corresponding micrometer readings, that is the reverse current. So 10 divisions are equal to 5 volts, so 1 division is equal to 0.5 volt. So if I keep at 2 divisions here like this will be equal to 1 volt. For 1 volt, there is no deflection in the micrometer, there no current flows, no reverse current. So like that we can gradually will increase. So now I am keeping at 5 volt. 5 volt also there is no change in the micrometer, that means no reverse current. 6 volt, 7 volt, like that increase. Now I am keeping at 10 volts. Still there is no change in the micrometer. From 10 I am changing to 11 volt now. I am keeping at 11 volts. 2 divisions are there. 10 divisions are 20. So 1 division will be equal to 2. So 2 divisions means 4 microampere. So 4 microampere for 11 volts. Now keep it at 12 volts. 12 microampere. Now change the reading to 13 volts. This is 13 volts. 13 volt we are getting 24 microampere. 24 microampere. 2 divisions after 20, so 24. So 1 division is equal to 2, 24 microampere. Then 14, and this is 14 for 14 volts. 34 microampere. 34 microampere. 34 microampere. Then 15 volts. 44 microampere. Now we will draw the characteristics curve for the reverse bias. For that we have the tabulated reading VR, reverse voltage V, and also the reverse current taken in microampere. So that you can see from the tabular column. So draw the graph by taking negative x-axis, by taking VR along the negative x-axis and IR reverse current IR along the negative y-axis. So you are seeing the graph. So here also up to 10 volts there is no reverse current, and when the reverse voltage is increased beyond 10 volt, there is a slight increase in the reverse current, that also in very small value in microampere. This reverse current is due to the minority carriers crossing the junction of the diode. Hope you understood the process involved in studying the characteristics of PN junction diode. We'll meet you in the next video with yet another demonstration. Thank you for watching. Bye bye.